hierarchies, it will help us create drill downs. So Tableau will automatically understand some of the hierarchies, like when you have country, state, district, city, and postal code. Tableau will understand these as a hierarchy, and whatever drill down which we do, it will come as where we can drill down from higher level to lower level. So let's say if I have a value, so 2297201. So 22,97,201 is the value for United States. So let's say if I take drill down, I'll just remove this region. Okay. So if I drill down to the next step, so what are the states in each and every country? So just click on this drill down. So you can see these many states are there in each and every country, and that 22,97,201 is split across all these states. That means that value is getting distributed. So in the same way, let's say in our country, we have a population of 120 crores. And if it is splitting across each and every state, so you might have 10 crores for each state, and some states you have 5 crores and all. So likewise, the sales amount also is distributing across each and every state. So if I drill down more, so you can see there is a next level cities. So what are the number of cities that are available in each and every state? And those values will also get splitted accordingly. And you can drill down up to postal code. So this way we need to create hierarchies to create the drill downs and all. So sometimes if this, I mean, Tableau has automatically created this. So in this sample superstore example, it's already been built. So now I will show you how to create a hierarchy by using some other columns. So I will just arrange it in folder arrangement. So I'll just take some other columns. Let's take category, subcategory. So it's already in that format. Regional manager, ship mode. Okay, so let's take these two columns. So these two columns are separately, I mean, separate columns. So you don't have any drill downs or anything. So ship mode. Okay, so if you take normal columns, you won't see that drill down option. So only when you drag country column, so then only you see this expand collapse button. Why? Because for this, there is a hierarchy model that is attached. So if you see the normal columns, it doesn't have that icon. You can't see that expand or collapse symbol here. So to see that symbol, okay, so you right click on this, go to create, sorry, not to create. There is an option called hierarchy. You can add to existing hierarchy. So there are two existing hierarchies available, which is location and product. So location is which we have seen for country, region, state, city, postal code, all those will be. So a hierarchy is already been created. So now I will create for regional manager and ship mode. So regional ship, I will say okay. So I have one column in this. I want to add ship mode also. So you can directly right click on this and go to hierarchy and add to regional ship. So this way you can add, or you can directly drag and put it in the folder. So here it is so here you can see regional ship. This is a hierarchy model. So you can see the icon also. So for a hierarchy, this is a symbol. So if you see this symbol, you can identify it as a hierarchy model. And I will drop ship mode into the hierarchy. Okay, now if I drag and drop this column, so now I will see this expand collapse button. So if I expand this, so I can see what all ship modes available in each and every regional manager. So this way, if you know your data, and if you know if the data is coming in such a way, let's say I know countries will have states, and states will have districts, and districts will have cities. So this is a normal hierarchy which we all know. And we have one more example, CEO, Vice President, Manager, Senior Manager, and Associate Manager. So this is some orders which we know for hierarchy. In some cases, let's say if you see category, subcategory. Okay, category, subcategory. What are the subcategories that are there in each and every category? So by seeing the names also, few of them we can understand that this is a hierarchy. So in categories, we will have subcategories. So in our organizational data also, so they will provide you such type of information where you will know in this particular value, you will have subcategories or sub levels in that column. So if you know that, we can arrange, we can create hierarchies so that we can use this drill down option. So not only here, so in the worksheet as well, you will see this collapse and expand button where you can collapse like this. Okay, so there are many of, like in product, if you see, if you go to, yeah, product hierarchy. So there are 4 values which are there. Okay, you can start from category. In categories, you will have subcategory. In subcategories, you will have manufacturer. For every manufacturer, you have different products. So this particular Atlantic manufacturer manufactures these many products. So those are information we can get to know by using hierarchies. So hierarchies can be created by right clicking on any of the dimension and just go to hierarchy and create hierarchy. So if it is already there in hierarchy and you want to remove it, so just right click on that, go to hierarchy and remove from hierarchy. So it will be removed from this hierarchical folder. So that's about hierarchy. So the main use of, yeah, Prashant. Yes, we can drag and we can use. Let's say country is there. Okay. So usually after country, what you will get is state. So without that, you can also drag from here and you can put it. Yeah. Yeah. So already hierarchy is created for these 5 columns. So whenever you drag, this plus and minus will be shown until unless you remove all this from hierarchy. So I'll just remove from hierarchy. So I've just selected everything. Control select the columns and click on remove from hierarchy. So I have removed those country, state, everything from hierarchy. Now let's see what it will show. Now it will not show any plus symbols. So now I can't drill down. So after country, I don't see state or something. So I need to select state again here and put it here. State also I can't drill down. Yeah, so I'll show you how to create hierarchy. So I'll go to country. Yeah. So right click on this, go to hierarchy, create hierarchy, and I'll name the hierarchy name as location. So currently only country column is there, and state I want to add. State, go to hierarchy, add to location. Okay, add to location, it will add it to the location. So now you will have 2 columns. So likewise, city after that, and postal code. So postal code also you can just drag and drop it over there, or you can just directly right click and go to hierarchy and add to hierarchy, or you can directly drop it here. No. Profit discount restriction. Only for dimensions we can do. For any dimension column we should do, but there should be some rule. So we know that countries will have states. We know that states will have districts. So in the same way, if you know in your data, so there is some hierarchical arrangement, and if you know that, then you can create a hierarchy. Otherwise, you can't use some normal random columns. You can't do this hierarchy. There has to be so one above the other or one below the other. So you should know that countries will have states. Then only we should create a hierarchy for that. In some cases, if you see, let's say segment is there and region. So these are two different columns. Okay. Central has segment, each and every. So there is no difference. For every segment, there is a region. But if you see in the country, whatever that particular country has the number of states, let's say the states which are there in Canada will not be there in United States. The states which are there in United States will not be there in Canada. So that has to be one process. If you see this example, consumer corporate home office is there in central, same consumer corporate home office is there in east. So you should know the columns, and you should know that it is a hierarchical arrangement. So that state countries will have states, states will have cities. So if you know all this hierarchy in your about your data, so then only you should create this hierarchy. Is it clear? Mm-hmm. Yeah, we can use in any other charts. Yes. So I'm just showing it in this one, but we can use it in any other charts. So let's say country and sales. So bar chart is there. Okay, so if I do an extension, if I do a drill down, so you will see the bars accordingly, like this. Not only in the bar, you can also use some pie charts as well. Yeah, for pie chart, we will use only not more than 6, so it won't show you. So let's take a tree map. Yeah, so like this, you can expand. Okay, any other questions? Okay, so now we will discuss about dimensions and measures and blue and green pills. So earlier we have discussed about dimensions and measures. So dimensions are nothing but descriptive part, descriptive and names, okay, which cannot be, where we cannot do mathematical operations, where we cannot do mathematical operations. So these are called as dimensions, and measures, which are measurable, where we can do mathematical operations, and these are like values, numbers, like this. These things. So let's see in Tableau how it takes. Okay, so we have customer name. So this is a dimension as it is a name. And whenever I drag any dimension into the rows or column shell, so by default, this will be blue pill. By default, any dimension that you drop, will be blue pill. Okay. So if you take any other dimension, it will be blue pill only. And only in case of date column. So let's say date column. Okay, so this can be converted to a green pill as well. So green pill and blue pill, what is the difference between green pill and a blue pill is? So green pill is continuous. Blue pill is discrete. Blue pill is discrete. So where we create axis related charts by using green pill. Hello. Hello. Can you hear me now? Okay. Okay. So I was telling about green pill and blue pills. So green pill is nothing but continuous and blue pill is nothing but discrete. So by using continuous mode, we create axis related charts. By using blue pill, we create tabular charts. Okay, so dimension can also be green. So there are cases where dimensions can also be green. Okay, so by default, a dimension will be blue. Why? Because it will have discrete values. So each and every value will be discrete. So that's the reason every dimension will be in blue color. So only in the case of date, let's say if I take a date, only in the case of date, we can convert this into continuous mode. Okay, so with this, what we can do is we can create charts which will have axis. So it will create an axis. So normal discrete mode, you won't see any axis. So it won't have any axis if you have it in discrete mode. So if you want to see in continuous mode, so then it will be like this and you will have axis for it. Now I will take sales. So now I can see a chart with two axes. So here I will have one axis and sum of sales will obviously be, so any measure that you take by default, it will be in continuous mode. So let's say if I go to a new sheet, so if I take this sales, so by default, any measure will be in continuous mode or green pill. So as we discussed here, by default for dimension, it will be blue pill. For measure, by default, it will be green pill. By default, it will be green pill. Green pill, nothing but continuous mode. Okay, so what I'm trying to tell you is, so there will be, like, we can convert a dimension into continuous, a dimension into discrete. In the same way, we can convert a measure into continuous, a measure into discrete. So what if you do discrete? You can see discrete value. So value separately. When you make it as continuous, you will see the axis. Okay, in continuous mode, you will see the axis. In discrete mode, you will just see the value. So if you want to create some axis related charts, so if you want to let in line chart or bar chart, in those cases, you can see axis. So let's say if I want to create a subcategory by sales. So this is showing me subcategory sales, but I want to see a chart, a line chart or a bar chart. So let's click on this. Okay, so this way I can see a bar chart. So that's how we can make use of continuous mode and discrete mode. So now let's see in the chart. Okay, so Tableau represents data differently in the view depending on whether the field is discrete or continuous. So continuous and discrete are mathematical terms. Okay, so continuous means forming an unbroken whole without interruption. So basically it will create an axis, which will say continuous axis. Discrete meaning individually separate distinct values. Okay, so whenever I take any, let's say if I take subcategory, by default it is a discrete. I can't convert this into a continuous. Only date dimension we can convert into continuous mode. So you can see this discrete and continuous mode only in this date column. So that's about dimensions. And now let's see about measures. So if I drag it, it will show me green pill, which is continuous mode. So by default measures will be in continuous mode. And if you convert into discrete mode, you can see the values. Okay, so we have green measures and green dimensions. So sum of profit. So by default, whenever we take any measure, that becomes continuous mode. And dimensions, year of order date. So only date column can be continuous mode. Other columns cannot be, other dimensions cannot be in continuous mode. And we have blue measures. So blue measures in the sense, whenever I convert into discrete. So I right clicked on this and I have converted into discrete. So when I did this discrete mode, I can see that particular value. And blue dimensions. So by default, every dimension is a discrete. Why? Because we will be able to see distinct values. So distinct values we are able to see. So without any axis, that means it's a blue dimension. So discrete values are treated as finite. Generally, discrete fields add headers to the view. So it will add headers to the view. Headers meaning you can see that country or region, that column name on top of the country names. So that way we can create blue pills and green pills. So possible combination where we can create different varieties of charts using blue pills and green pills. So let's just see some examples how we can make use of continuous and discrete. So in this I will just put discrete columns. Discrete dimensions I will put. So whatever dimensions that you take, all these are discrete only. Okay, in row shelf, what I'm putting, all these are dimensions which are blue. These are called as discrete. Okay, and I will also take sales. Sales. Okay, so by default, sales is coming as green, which is continuous. Later, I will convert this into discrete. So I'll just right click on this and click on discrete. Right click on this and click on discrete. Okay, so I can see distinct values of this. So these are discrete dimensions and measures. And in the next chart, next sheet, I will create continuous dimensions and measures. Okay, so only order date from dimension can be converted as a continuous mode. So by default, this will also be in blue pill. So if I want to convert this, only for order date, I will have option to make it as continuous mode. And I will take sales. So sales will always be in continuous mode. I mean, by default, it will be continuous mode. And when you right click on this, you can convert it to discrete. So not only that, profit also we can make it. Yeah, so you will see two different line charts, one for sales and one for profit. And year of order date, when we made it as continuous, so we were able to see it as, I mean, we will get this axis. Okay, so we can use axis related options and all. So that's about continuous dimensions and measures. Now I will create discrete dimension and continuous measure. So in this example, I will show you. So this is a combination of discrete dimension and measure. Both are discrete. Here both dimension and measures are continuous. In this example, I am going to show you discrete dimensions. These are my discrete dimensions, and I will take sales. Okay, here I am taking continuous sales. So I'm showing the value as sales, but you are not able to see the header. So you can just type in sales here. Sales hide field level column. So you can see that. And in other example, I will show you discrete measure and continuous dimension. Okay, so the only column which I can take is date column. Only date column I can convert into continuous mode. Other columns I can't make, so you will not see this continuous option. Let's say if I take an example of country, so you right click on this, you don't see that continuous or discrete option in other columns. Only in date column you will have this option. So I will make continuous and I'll take measure as a discrete. Let's say sales. So by default this is coming as a continuous mode, and I'll right click on this and make it discrete. Okay, so if I make it as discrete, so I will see the values like this. Okay, so the values will be shown in the axis, and this year of the order date is coming on the axis, that based on these values. So it is not the right way to show, but to show what is discrete measure and continuous diagram. So I'm just preparing this. So this is the way where you can have discrete measure and continuous dimension. Okay, so I'll just take a pause before continuing to the next slides. So if you have any questions, you can ask. Okay. Okay, so let's say notepad. I'll just open a new notepad. Okay, so dimensions mostly will be discrete. Mostly they will be discrete. And measures mostly they will be continuous. So this is one thing. And continuous mode will be represented in green pills. Okay, so you can just see and understand. Let's say these are blue pills. Can you tell me what are these blue pills represent? Whether it is continuous mode or discrete mode? Yeah, so discrete mode is nothing but blue pill. Okay, so in continuous mode, what all can be continuous? So dimension also can be a continuous mode. So in dimension, only order date or date columns only can be converted to continuous mode, and all measures also can be continuous. And in discrete, all dimensions, all measures, we can make it as discrete. So this is the like to convert into discrete mode or continuous mode. So this is the standards we follow, and mostly dimensions will be discrete, measures will be continuous. So now let's go and see. Okay, so whenever I drop any dimensions, so those are coming as blue pills by default. So these blue pills I can't convert into continuous mode. Only the date columns I can convert it to continuous mode. Okay, so this is a classic example for discrete dimensions and sales. So all measures can be converted into discrete mode. So when I do discrete mode, so I can see the value of this particular city or postal code value. I can see it here. So even by making it as continuous mode also you can see it. So there are other ways where you can see it. So I can just put it in the label. Okay, there are other ways where you can put, yeah, double click on this. So you can see in this way also. But when in some cases user want to see next to it, or if you want to put more columns after this, like say after profit and sales, if you want to keep some other columns, then you might not be able to keep, let's say if I drag any column. Okay, so specifically this ABC will always be available in Tableau. Why? Because to keep any measures in this, let's say sales, if I double click on this, so those sales value will go and sit in the ABC place. So every time that place is kept empty because to keep any measure values. Okay, so after measure values, if you want to keep any dimension, you can't keep. So if it is in continuous mode, let's say if I keep, I want to keep any value after this column. After this column, I can't keep. So it will come before this column only, but not after the column. So why? Because that last column is dedicated for measure. The last column which is there, that is dedicated for measures which are in continuous mode. So that's the reason. Let's say if I convert this into discrete mode. So let's say if I convert these into discrete mode, I can keep any other columns if needed. So I can see the profit and sales value. If I want to keep any other column after this, okay, I can see that. So usually this ABC value is dedicated for continuous measures. So that way we can, so this is the classic example of discrete dimensions and measures. So in this you can see dimensions are discrete, are in discrete mode, and sum of profit, sum of sales is also in discrete mode. So right click on this and see it has discrete mode. And in the next example, I'll show you the continuous mode. So both the dimensions are in, both the measures are in continuous mode. So only date column can be converted into continuous or discrete. So you can see here. So whenever we right clicked on other dimensions, you didn't see that option where you can convert into continuous mode. Only order date. So this is a date column. It's in date format. So you can convert this into continuous or discrete. And by default, this sales and profit is in continuous mode. And what is the difference between continuous and discrete is you will get the axis. So right click on this. So year of order date, you have it as an axis. So if I do a right click and make it discrete, okay, now you don't have any axis. So right click and see you don't have an option to edit axis and all. So right click and do continuous. So when you do continuous, you have edit axis option. So let's say in edit axis, you will have a lot of options where you can customize this axis and you can put any independent axis range and all. So those options will be available in continuous mode. And you can add reference line as well. And in discrete mode, you will not have all these options where you can't add any reference lines. Let's say if I want to add any reference line at the maximum, let's say, or average. Okay, so in that way you can create a, so it is taking average of all these years, which will be 2021 and 2022 middle. So that way you can show the average line. So that's about continuous dimensions and measures. And here I am combining both together. So discrete dimensions and sales I'm taking as continuous. So last ABC will take that place. So as that place is dedicated for continuous measures, and discrete measure and continuous dimension. So for whenever it is continuous, you will have access. So whenever it is not continuous, you will not have any access. So usually for measures, we definitely should have access. So if you see it here, sales has an access. Access meaning, so whatever value is there, based on that value, you can see the numbers and everything. So if the value is $494,040, so you can see through axis. So this is y-axis. In y-axis we have sales and profit. In x-axis we have order date. And in this example, we have sales as a discrete and order date as a continuous. So usually this should not happen. I mean, it's not the proper way to represent, but I'm just telling you that this is an option where we can still show sales in discrete mode and order date in continuous mode. Is it clear? Ah. Okay, so now we will discuss about functions in Tableau. So there are these many type of functions available. So number functions, string functions, date functions, type conversion, logical functions, and aggregate function. So we'll see each and every function one by one and how to use those functions in with a scenario and all. So let's take an example of subcategory and I'll take profit. Okay, so in profit, I have some negative values. So I'll just sort it. Okay, so there are some positive values and there are some negative values. And I will create a bar chart and I will sort it. And I'll show the label. Okay, so in this chart, I can see towards your right, you have positive values and towards your left, you have the negative values. And in some cases, I don't want to show this negative symbol, or so it is saying minus 1171. So anyways, we are showing in the graph, it is going in the negative direction. So then there is no point showing the negative value. So what user wants is, so I don't want to show the negative number or negative sign over there. So instead, I just want to show the number. So there is a function called absolute. So where it will just show you the number. So it will not consider whether it is negative or positive. So it will just show you the number. Absolute. And say okay. And absolute, put it in the label. Sorry, I have, so this is profit. So it will not consider whether it is positive or negative. Whatever value it is, it will show positive only. So by seeing the chart, we can understand whatever is in right side, we can consider it as positive, profitable. Whatever is in left side, we can consider it as negative profit. Or we can also represent with a one more condition. If sum of profit is greater than 0, then profitable, else non-profitable. And so this will be your color condition. And say okay. And if I put this in color, okay, so you can see profitable, I want to color it as green, non-profitable red, say okay. Okay, so this way I can represent which are in green is giving me positive profit, which are in red is giving me negative profit or non-profitable. And the numbers I'm showing here, all the numbers I'm just showing the actual number, which is an absolute number. Even if it is negative or positive, I'm just showing the number. So this way we can make use of a function called ABS. So which will not consider the negative values. So that's about ABS. Now we'll see another function. Yeah, ceiling. So there are three functions which are available: ceiling, floor, and round off. Ceiling, floor. So before I explain that ceiling and everything, I'll just show you. So, okay. What is the round off value for 25.53? Prashant, can you tell me? It's 26. So basically 25 after 0.5, whatever number you have, then it becomes the next integer, 26. If it is 25.4, then what it will become? This will definitely become 24 only. Sorry, 25. Yeah, 25 it will become. Okay, and let's say 25.6. Yeah, so this will become 26. So this is a normal round off thing which Excel does. Even in Tableau also it does. So let me just insert. Okay, so this is decimal and normal round. Okay, what is the value for this? 26. For this, 25. 26. Let's say 30.2. This will be 30. Okay, ceiling is some function where it will take the highest integer. Ceiling. Okay, so rounds a number to the nearest integer of equal or greater. Okay, so this will take the equal or greater. Even if it, let's say in this case, so 25.53, which is 26. So it will give it as 26. And 25.4, which is actually 25. But ceiling function will take the highest integer. Instead of taking the lowest integer, it will take the highest integer. So it will convert 26 only. So it will not consider the lowest value. It will just take the whatever might be the value after decimal place, 25.1 or 25.2. So it will not consider the value after decimal. Even if it is 25.2, it will take it as 26 only. So it will take the highest integer. So that's the use of this ceiling function. And yeah, Prashant, can you tell me for 25.6 what will be the ceiling value? Yeah, Divya, can you tell me what will be the value for 30.2 by using ceiling function? 31. So it will take the highest integer. Even if it is 30.2 or 30.6, it will give you 31 only. Let's take this is 25 here. And let me give you one more example, 25.3. What will be the ceiling value and what will be the round value? Prashant, can you tell me? What will be the round value? Okay. Yeah, perfect. And 26.3. Divya, can you tell me what is the round value and what is the ceiling value for 26.3? Yeah, perfect. Okay, so likewise, we have one more function which is floor. So floor will take the lowest integer. Okay, whatever might be the number after decimal, it will take the lowest integer. So can I will complete this thing? Can anyone tell me what is 25.53 for floor? Prashant, can you tell what is the value? It will take the lowest integer. Mm-hmm. No, 25. Yeah. So usually, so 25.53, it can become 25 or 26, right? So in normal round figure option, this is 26. But in ceiling, we are taking highest integer, but floor, we will take the lowest integer. Okay, Divya, can you tell me for 25.4? Sorry? Yeah, 25. Prashant, 25.6, what is the value for floor? Yeah. Divya, for 30.2, what is the number? Yeah, yeah. So this way we can complete for everything, which will take the lowest integer. Yeah. So if you see, this ceiling and floor will never match. Why? Because here we are taking highest integer, here we are taking lowest integer. So that's the use of this function. So I'll just write it in the calculation. So let's take sales, make it discrete to see the individual value, and mark it as, I'll just take United country column. Okay, and make the format. I don't want to see all those decimals. I'll just show only 2 decimals. Okay, so this is normal sum of sales, where I can see up to 2 decimals. If you do a round off, so it will be mathematically whatever number it is there, it will show you. So now I'll write ceiling of sum of function. Ceiling of sum of sales. Say okay. Double click on this. Right click on edit. Say okay. Yeah, so it is doing the round figure. Edit. I'll just drag sales again and write ceiling of function. So you can just type in and you can enter this. Expected equal to real actual integer. Okay. So let's create it in differentiate. Okay. Sales, I will keep it here. And I'll take country. I'll make this as discrete. Right click on this, click on format and make this as go to pane. Okay. So 29,333.49. 1 second. I'll write just sum of sales. Say okay. Okay. So usually, mathematically, this becomes 333, I guess. So I'll just format. So if I don't show any decimals, okay. So mathematically, this is 29,333. But when you use ceiling function, it is taking 334. So as per ceiling function, it has to take the highest integer. So that's the reason it is taking highest integer. And for 2297200, so what will be the ceiling value for this? Prashant, can you tell me what will be the ceiling value for this? Yeah, perfect. So that will be 2297201 is the one. So that is taking highest integer. So this way we can make use of ceiling function. And I will tell you about floor as well. So I'll just remove floor. And say okay. And Divya, can you tell me what will be the floor value for Canada? 29,000. Yeah, perfect. Yeah, Prashant, can you tell me what will be the floor value for United States? Yeah, perfect. So that will be your floor values. So this way we can make use of this ceiling and floor functions. So it depends on the requirement. Sometimes user doesn't want to do the comparison. So let's say if you are giving any, like if you are going to any mall or anything. So let's say if you have an amount of 999 rupees, so we end up giving 1,000 rupees to the person, and we might not take the change. So in that way, there we are rounding it off to 1,000, or even if it is 995 or 994, we will give 1,000 rupees and we don't take any change. So usually 994, if you do a round off, it might become 990. But in such cases, we are taking the highest integers. So there are some certain scenarios where in the business also they want to see, instead of taking the lower integer, or instead of rounding off to the mathematically, we do mathematic, and sometimes we take the highest integers. So that's the use of this ceiling and floor functions. Yeah, so we have 2-3 slides more, so we'll continue this tomorrow. So any questions from today's session? Negative values. So yeah, అవును, నెగటివ్ అనేది చూపియట్లేదు. అది చూపియద్దనే అబ్సల్యూట్ ఫంక్షన్ రాశాను. హ్మ్. అవును. వాయిస్ లో వస్తుంది, ఒకసారి మైక్ దగ్గర మాట్లాడదాం. ఆహా! ఓకే. 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 అర్థమైంది. కానీ కలర్‌లో నేను అది వాడలేదు. ఇప్పుడు ఏదైతే నేను కలర్‌లో ఏసానో, కలర్‌లో నేను నార్మల్ సమ్ ఆఫ్ ప్రాఫిటే వాడాను. నార్మల్ సమ్ ఆఫ్ ప్రాఫిట్. అంటే ఇది కలర్ రెడ్ కలర్ చేయదంటున్నావా? హ్మ్. ఆహా! నెగెటివ్ సైన్ కనపడొద్దన్నాను. ఎట్లాగో రిప్రజెంట్ చేస్తున్నా అది నెగెటివ్ ప్రాఫిట్ అని. రెడ్ కలర్ అంటే నెగెటివ్, అంటే non-profitable value. Sometimes user don't want to see that negative sign. So in such cases, we use this absolute value and make it number as normal number. And instead of representing with a negative sign, we just represent with a negative direction bars with red color. Okay, you were asking about some question, right? You can ask now. ఏదో అడిగారు కదా అప్పుడు